All right, chapter 1, section 8a, we're talking about quadratic inequalities. So same thing we did yesterday, but now instead of linear, we have quadratic. So it's going to be x squared, right? That's it. The only thing. What we need to make sure that we are paying attention to is you want to get your inequality either greater than, less than 0, right? If it's a quadratic, we move everything to one side and then we're going to factor. If it doesn't factor, we complete the square, use quadratic formula. But we have to get everything on one side. Then we're going to solve the inequality as if it were an equation because you're finding what we call test points. We're going to put them on a number line and then we're going to test the areas that work and the areas that don't, and then we'll do our interval notation. It's very simple. So here we go. I'm going to go through all the examples. 1, 2, and 3. Actually, 1, 2, 3, and 4 are all pretty similar, but we're going to do them all together. First thing we look at is our quadratic all on one side and zeros on the other. Yes, okay. So let's talk about that inequality sign. What does that inequality sign say? Less than. What is and, right? And. What kind of dots are we going to have? Open. And if we have open, where do we color? For and. In the middle, okay. And then what's our notation for interval notation? Do I have brackets or parentheses for an open circle? Parentheses, perfect. Okay, so now we're going to treat this just like an equation. We're going to factor. What are the factors of -3 that multiply to give me -3 but add to give me -2? -3 and +1. So we said equal to 0. So I have x equals 3 and x equals -1. Everybody agree? Okay. So let's put this on a number line. -1 is here, 0 and 3. What kind of dots do we have at -1 and 3? You guys said open. And from the beginning, where did we say we were going to color? In the middle, all right? So let's check. We always have to check our quadratics. Make sure. Always check 0, guys. It's the easiest one to do. So the way that we have this shaded, if I plug in 0, should it make the inequality true? Yes. So let's plug it in. 0 squared minus 2 times 0 minus 3 is -3 less than 0. Yes. So did we shade correctly? Yes. So my interval notation from left to right, where do my values start? Where do they end? -1 to what? 3. And what goes on the end of -1 and 3? Parentheses. There you go. Easy enough, yeah? All right, let's look at 2. Is everything on one side and zeros on the other? Okay, so let's talk about our inequality sign. What does that one say? It says less than. It's another and one. Talk about my dots. Are they open or closed? Open. If it's an and problem, where do we shade? In the middle. Good. And then if it's open circles, what's the notation for my interval notation? Parentheses or brackets? Parentheses. Perfect, guys. So now we're going to treat this as if it were an equation. Find our test points. What are the factors of -6 that multiply to give me -6 but add to give me -1? +2 minus 3. So x equals -2 and x equals 3. So I have -2 on my number line. I have 3 and I have 0. What kind of dots do I have at -2 and 3? Both of them are open. And where did we say that we were going to shade? In the middle. Okay, let's check to make sure we didn't make any mistakes here. If I plug in 0 with the way that I shaded, should 0 make the inequality true? Yes, so plug it in. 0 squared minus 0 minus 6. So -6 is less than 0. Yes or no? Yes. So did we shade correctly? Yep. What's my interval notation answer? How do I write that? -2, comma 3. What goes on the end of both? Parentheses. Perfect. Yeah. Yes, it has to go left to right. Like if you did 3 to -2, that's a problem. You got to go left to right. All right, let's look at number 3. Same thing. Everything on one side, 0 on the other. All right, let's talk about our sign. What does that sign say? That's an or statement. That says greater. So what, greater than or equal to, what does that say about my dots? They're closed. If I have an or statement, which way do I shade? on the outside, the opposite direction. And then what am I going to use with closed dots? Brackets. I think it's a good idea at the very beginning to give yourself this hint. So now we treat this as if it were an equation. What are the factors of negative 20 that multiply to give me negative 20, but add to give me negative 1? What is it? Minus 5 and plus 4. Okay. So x equals 5, x equals negative 4. What kind of dots do I have at both? Closed. And where do we say we shaded? On the outsides, okay. So in this case, guys, if I choose 0 to plug in, should it make my inequality true? No. With the way that I have shaded, should 0 make your inequality true? No. So plug in 0. 0 squared minus 0. Negative 20. Is negative 20 greater than or equal to 0? No. So did we shade correctly? Yeah. I don't have, the way that I shaded, I don't have 0 included in my solution set. So I plugged in 0 and it did not make the inequality true. That means we did shade correctly. So from left to right, guys, this is negative infinity over here. This is positive infinity over here. What is my interval notation? No. Where you start from the far left. Negative infinity to what? Negative 4. What goes on negative 4? A bracket. Then there's a gap. How do we say there's a big gap? A U. Perfect. Then what? Bracket. 5 to infinity. What's on infinity always? Parentheses. Perfect. Good job. Good job, guys. Yep. How's 4 a little bit different? There's a coefficient on an x squared. We've got to remember how to factor, guys. But everything is on one side, set not equal to 0, but your inequality sign then 0. So let's talk about this inequality sign. What does it say? Greater. So this is an or statement. Is it or equal to or just or? Okay, so open or close dots? Open. Which way do we shade if it's or? Outside. Good. And then what do I use as notation? Parentheses or brackets? Parentheses. Good. Remind yourself every time, guys. So now let's talk about this. We're going to factor as if this was an equation. What are the factors of negative 24? Give me negative 24 when I multiply and a negative 5 when I add. So x squared minus 8x plus 3x minus 6 equals 0. If you want to do my shortcut, that's fine. Just make sure you divide both terms by 4. What can I take out of 4x squared and 8x? 4x. So I'm left with x minus 2. What can I take out of 3x minus 6? A positive 3. And I'm left with x minus 2. Good. So I have my one parenthesis of x minus 2. I have one parenthesis of 4x. Where's my back? 4x plus 3. You guys agree? Equals 0. So my two test points here are x equals 2 and x equals negative 3/4. So on a number line, negative 3/4 is to the left of 0, 2 is to the right. What did we say about our dots at those 2 points? Open or closed? Open. And this was an or statement, so you said we were going to shade which way? Left and right, correct? Okay. So the way that I shaded, if I test 0, should 0 work? No, so let's try 0. Is negative 6 greater than 0? No, because if I plug in 0, guys, 0 squared is 0 times 4 is 0, minus 5 times 0 is 0, minus 6. Negative 6 is not greater, so we are correct with the way that we shaded. So how do I write my interval notation from left to right? Where do my values start? Parenthesis, negative infinity, to negative 3/4, parenthesis, u, parenthesis, 2, and parenthesis. Good. Anthony. Okay, do you see how we shaded in these two directions, right? So 0 is not shaded. So the way that we shaded, whatever is shaded is part of our solutions. Anything over here that you plug in will make your inequality true. Anything you plug in here. So since 0 is not shaded, it should not make our inequality true. So when I plug in 0 here, this is 0, this is 0. So the statement becomes -6 is greater than 0, which is not true, which confirms that it's not part of our solution set. So if it's shaded over 0, then 0 should work. If it's not shaded over 0, then it shouldn't work. You can choose anything you want. I just always pick 0 because it makes the math easy. Yep, anywhere. All right, guys, 5 and 6 are a little different. Just want you guys to see some things. There's two things that you should notice here. We're talking about quadratic inequalities. First of all, not everything is on one side. And it's not simplified. You can't just set x equals 0, x plus 1 equals 0, and 12. You have to multiply everything out, whatever you need to do to simplify, and move over. So the first thing we're going to do is distribute. We have x squared plus x. What can I do with the 12? I can minus the 12, and then I have less than 0. Now, this is the problem we've done 4 times. What does this sign tell me? It's an and, all right? That tells us a lot. What kind of dots do I have? Open, parenthesis, good. And where am I going to shade if it's an and? In the middle. Perfect. So find your 2 test points. Factor it. What are the factors of -12 that multiply to give you -12 but add to give you 1? Good. Plus 4 minus 3. So x equals -4, x equals 3. So on your number line, -4, you got 0, you got 3. What kind of dots did we say we had? Open, perfect. This is an and or an or? What did we say at the beginning? It's an and, so we're going to color where? Shade in the middle. So the way that we have this shaded, should 0 satisfy our inequality? Yes, so we'll go back to the beginning. If I plug in 0 here and 0 here. What's 0 plus 1? 1 times 0. 0. Is 0 less than 12? Yes, so that is correct the way we shaded. So what is our interval notation? Parenthesis, -4, comma 3, close your parenthesis. I know you guys look at this and go plus or minus 4. I get it. Let's go through the motions, though. Is everything on one side and 0 is on the other? No. So let's move it over. X squared minus 16 greater than or equal to 0. Let's talk about the sign. What does it say? X squared minus 16 is greater, right? So this is an or. What do we know about our dots? They're closed. And if it's or, which way do we shade? Outside. Perfect. And if they are closed dots, what do we use? Brackets. Good job, guys. So this is x plus 4, x minus 4, right? You guys agree? So your 2 spots are +4 and -4. What kind of dots do we have? Both are closed. Good. And since it was an or, which way did we say we shaded? Outside. Good. So if I check 0, should 0 be part of my solution? No. Because it's not, we don't have it shaded. So let's just check. What's 0 squared? 0. Is that greater than or equal to 16? No. So we're good to go. So from left to right, guys, how do I write this in interval notation? -infinity to -4. Then what? Bracket. Good. U. Bracket. 4, comma what? Perfect. Good job, guys. All right, the last 2 are just variations of things you might see that are not as straightforward as the last 2. Nothing you guys can't handle. Quadratic, x squared, right? Yeah? Yes? I know y'all are working ahead. Just work with me for a minute. Do I have everything on one side, 0 on the other? So if I move this over, I have x squared plus 4x plus 1 greater than 0. Everybody with me? Okay, so let's talk about the sign. What does the sign say? Or, right? Greater. What do I know about the dots? They open or closed? I have open circles. If it's an or statement, which way do we shade? Outside. Perfect. And what do I use? Parentheses or brackets? Perfect. All right, guys, factor this. Factors of 1 that multiply to give me 1 and add to give me 4. Oh. So that means we have to do what? One of two things. Complete the square or quadratic. I'm going to complete the square. Good. I'm glad you said that. So let's complete the square. If you want to do quadratic, do quadratic. See if you get the same thing I do. I'm going to move 1 to the other side. See if we remember how to complete the square. What do? I'm going to take my 4 and do what? Divide it by 2. And what do I get? 2. So on the left-hand side, my parenthesis is x plus 2 squared, correct? So then we square it. So 2 squared is 4. 4 goes here. Everybody with me? Okay. So negative 1 plus 4 is 3. All right. Now what? Take the square root. Good. Guys, when I take the square root, what goes in front of my answer? Perfect. And then what's the last step? Minus 2. So you get x equals negative 2 plus or minus the square root of 3. If you did the quadratic formula, what's an extra step you have to do? You got to divide everything by 2. You got to factor out the 2. So, guys, nothing is different about this problem. Nothing is different about this problem. What is a little maybe confusing is where negative 2 plus root 3 and negative 2 minus root 3 are. Where do I put them on a number line? Where is it in regards to 0, we'll say? They're both less than 0. Thank you, sir. You guys are like, how does he know that? The square root of 3. Do you guys know exactly what it is? No. But what's the square root of 4? 2. So the square root of 3 has to be less than that, right? So negative 3 plus a number that's less than 2 is, negative 2 plus a number that's less than 2 is still going to be less than 0. So don't get yourself hung up on that. Just think a little bit. So when I talk about these two, it's negative 2 minus root 3 here and negative 2 plus root 3. You need to know which one comes first, which one comes second. Obviously, the one that's minus is going to be before the one that's plus. If you're subtracting, it's going to go less. Does that make sense? What kind of dots do I have here? They're both open. And which way did you say you're shading? The outside. So in this case, guys, did we shade over 0? Yes. So should 0 work? Okay, plug it in. 0 squared plus 4 times 0, that's all 0, is 0 greater than negative 1? Yes, so we shaded correctly. So how would I write my interval notation from left to right? Negative infinity 2, negative 2 minus root 3. Hold on, what goes on the end? Parenthesis, then what? U, then what? Yep. Negative 2 plus square root of 3, comma what? Infinity and a parenthesis. Good. Good, good, good. All right, last one, and then I'll stop yapping. How's this one different? It's x to the third. How many test points are we going to have here, guys? 3. Do we know how to factor this cubed? Yes. In this case, the open or close thing is still going to matter. The parenthesis versus bracket is going to matter, but the and or, you're not going to be able to say, oh, this is exactly where I shade. You're going to have to actually plug numbers in. This one's a little more computational work. But the first thing I have to do before I do anything is what? Not yet. I've got to add the 48. I've got to move this over. I have 2x cubed minus 3x squared minus 32x plus 48 is greater than 0. We still know that this is what kind of a circle? Open or closed? Open. And when we have open circles, what do we use? Parentheses or brackets? Parentheses. And we're actually going to have to test values here because you have more than 2 points. So when we have 4 terms, guys, how do we factor? We factor by what? Grouping, okay? So the first 2 and the second 2. Remember, include that sign. So what can I take out of 2x cubed minus 3x squared? X squared, okay, and I'm left with 2x minus 3. What can I take out of negative 32x and a positive 48? Minus 16, and I'm left with 2x minus 3. You guys agree? Okay, so my parentheses are 2x minus 3, and then I have 2 more parentheses. What are they? X plus 4 and x minus 4. Where'd you guys get that from? The x squared minus 16. Okay, good. Good. So in this case, I have x equals 3 over 2. I have x equals negative 4, and I have x equals positive 4. So I have to test areas. I have negative 4 here. I have 0. I have 3 over 2, and I have 4. What kind of dots do I have at all of those points? Open. So I have an open one here, an open one here, and an open one here. So we need to see where we have to shade. We're going to have to pick some points, guys. We're going to have to pick some points and plug in. So the first thing I want to do is check this area here. Anything to the left of negative 4. So pick a number that is less than negative 4. Negative 5, okay? We got to throw it in here. So I have 2 times negative 5 cubed minus 3 times negative 5 squared minus 32 times negative 5. Is that greater than negative 48? Okay, what's negative 5 cubed? Negative 125, right? Times 2? Negative 250. What's negative 5 squared? 25 times negative 3. Negative 75. What's negative 32 and a negative 5? Plus 160. All right, is that greater than negative 48? It's not. So do I shade over here? No. All right, check the next section. What's the easiest number to throw in here? 0. If I plug in 0, I have 0 is greater than negative 48. True? Okay, then I shade in here. Check this section. Something between 3 halves and 4. 1, 2, 3. Okay, so 2 times 3 cubed minus 3 times 3 squared minus 32 times 3. Is that greater than negative 48? What's 3 cubed? 27 times 2? 54. All right, 3 squared is 9 times 3 is negative 27. Minus, what's 32 times 3? 96. Is this going to be greater than negative 48? No. All right, some of you can do that in your head and go, oh yeah, it's not going to work. Some of you are like, how do you know that? You guys, then you have to do it. You have to say 54 minus 27 minus 96. But no, that's not going to work. That section won't work. So now we got to pick a number in this section just to make sure. 5, okay. So I have, make sure I write this down right. 2 times 5 cubed minus 3 times 5 squared minus 32 times 5. Is that greater than negative 48? Well, what was negative 5 cubed? Negative 125. So 5 cubed is 125 times 2 is 250. Minus 75 plus 160 or minus 160? Minus 160. Is that greater than negative 48, guys? Yes, it is. So this section works over here. So when you have more than 2 points, you have to check each section. You got to go to the left, you got to go to the middle, you got to go to the right. You got to see what works, what doesn't. So if you guys notice here, there's 2 sections that work. Reading from left to right, what is my interval notation? Where do the values start to satisfy the inequality? At negative 4. Does it include negative 4? No. So it's negative 4 to where? 3 over 2. Perfect. Included or no? No. And then how do I say and? U. And then where does it begin again? To where? That's it. That's the hardest problem, and it's only because computation-wise, you got to plug in a bunch of numbers. But mathematically, Algebra 2 honors, that's not too hard for you guys.